Hi everyone, this is a video to go over 5.5, which is on the substitution rule. So I like to think of this rule as kind of the opposite of the chain rule. So how to do the antiderivative of some types of composition functions, where you have like a function composed of another function. Okay. The actual rule is here. If you're interested, I think it's much easier if we just do some examples to show how to do substitution. Okay, so let's look at this example here, example 1. So we have x cubed multiplied with cos of x to the power 4 plus 2. So far we've learned a lot of antiderivatives, but we haven't done any antiderivatives of functions that are composed of other functions. So in this case here, what I mean by that is inside the cos function, we have another one, which is x to the power 4 plus 2. So far, we would have just done an antiderivative of cos x. So when you have this type of composition of functions, one strategy that sometimes works is substitution. And so what you want to start by doing is making a substitution for this inner function. And we use, instead of saying substitution, they actually call it u-Substitution, just because traditionally we use the letter u to make the substitution. So we're going to sub out the x squared, or x to the power 4 plus 2 with a u. Okay, so we're going to change all the variables into u's. So we're also going to sub out the dx, and the way that you do that is you find the derivative of u. So du by dx would be, so the derivative of u with respect to x would be 4x cubed plus 0. Okay, so when I sub out the dx, all I have to do is just rearrange this by multiplying by dx on both sides. So I'd have du equals 4x cubed dx, and then divide by 4x cubed. So I'd get, you'll get so used to this, you can do this in one step later on. Dx equals du over 4x cubed. Okay, so I'm going to be subbing out the u, or the x to the power 4 plus 2 with the u, and I'm going to be subbing out the dx with du over 4x cubed. So we'll see what we get in the next step. And remember, this dx came from taking the derivative of u. Okay. So I still have that x cubed at the start. You'll see what happens to that in a second. Cos, so instead of having this tricky x to the power 4 plus 2, now we just have a nice simple u inside. Let me just highlight that in yellow. And then instead of having dx, I have du over 4x cubed. We haven't changed this integral at all. We've just made substitutions that are equal to their other parts. It's just making it look simpler. Now, notice what we have. We have an x cubed in the numerator here, and then we have an x cubed in the denominator. So these actually cancel out. So that's actually really nice. And then we have a division happening by 4 there. We can pull the 1 over 4 out because it's just a constant. So this is 1 over 4 times the integral of cos of u du. Cool. So that turned it into something that we know how to evaluate. So again, what you do is you take that inner piece that probably looks complicated. You make that your u. You take the derivative of that in order to sub out the dx. Okay. Usually there's going to be some nice cancellation that occurs, and you'll end up with a really nice integral. So to do this integral, we have, so the antiderivative of cos of u would be sine of u. And then remember, you need your plus c. That's not the final answer because in the original question, there's no u term. So we need to write our final answer in terms of x. So last step, we just sub back in what u was equal to. So sine of x to the power 4. Actually, I'm going to write this on this line. 1 over 4 sine x to the power 4. Oops. Plus 2 plus c. So that's the answer. I want to leave space at the bottom because you can check your work. One thing I like about integrals is that you can always check your answer. Remember, integrals are opposites of derivatives. So if I have my answer there, I can check if it's correct if I take the derivative of it and I get what's in the integral back. So I'm just going to double check. You don't have to do this every time, but like on a test or something, like when I used to be doing calculus tests, I would always go back and do this to all my integrals. So take the derivative of your answer and you should get the original function that's in the integral back. Let's see. Oops, yeah, no, this is right. Okay, so to do this integral, the 1/4 is a constant, so just leave it. You would need the chain rule, right? So for the chain rule, you take the derivative of the outside, so that would be cos. Cos of x, leave the inside as it is, multiplied by the derivative of the inside. So the 4 would come down and you would have x cubed. The derivative of 2 is 0. And the derivative of c is 0. The 4's cancel, and you get x to the power of 3 times cos x to the 4 plus 2. Oh my gosh, look, that matches exactly what we have in the original integral. That's how you know you got the answer correct. Okay, so you can do that anytime you do an integral. If you take the derivative of your answer, you should get the original thing in the integral back. Okay, I'm not going to do that every time, obviously, because it takes so much time, but I just want you to be aware that you can check your work that way and find silly mistakes that are easy to make since there's so many steps in these questions. Okay, next one. This one's actually going to be more simple. So this is the inner function, the 2x plus 1, and then the outer function is that square root, right? So usually you're going to want to make that the u-substitution with that inner function. And then remember, you take the derivative of u with respect to x to find out what dx is. So the derivative would just be 2. Rearrange that, you can cross multiply, so dx would be du over 2. Okay, so that's what we're going to sub in for dx. And make our substitution. So we'd have root u du over 2. Cool. I'm just going to rewrite it so the 2 can come out front. Root u, I'll write it as u to the power of 1/2, just because it'll be easier to do the antiderivative that way. Okay, and this is a power, so I'm going to bump the power up by 1. So 1/2 plus 1 is 3 over 2. Divide by the power. Dividing by 3 over 2 is the same as multiplying by the reciprocal, so I'll do that just nice and clean. So 2/3. And we need to add our plus c. Let's make that look nicer. So it'd be 1/3 u to the power of 3 over 2 plus c. And last step is we need to sub back in order to write our final answer in terms of x. So it'd be 1/3 2x plus 1 all to the power of 3/2 plus c. And remember, you can take the derivative of that and see if you get that answer as your solution. Sorry guys, I'm just going to double check I've got the right answer there. I don't want to make any silly mistakes either. Okay. Yay, good. Okay, next question. Ooh, this one looks tricky, right? If you looked at that originally, you're going to think, okay, I've got a square root, I've got a fraction, like this looks horrible. When you've got something in like a smaller function inside a bigger one, you always want to try u-substitution first. It's really going to be helpful. So we're going to sub out this little guy here, 1 minus 4x squared. And once you do the u-substitution, this is going to look so much nicer. Du by dx would be negative 8x. Remember, you cross multiply, so dx would be du over negative 8x. So that's what I'm going to sub in for dx. So I'd get, this x is still going to remain there, don't worry about that, over root u. And then I'm going to have dx over negative 8x. So the cool thing is usually with these substitution questions, you're going to have a nice cancellation that happens. So any leftover x's should be canceled out. If that's not happening, then either substitution is not the right strategy or you've made a little error somewhere. Okay, so let's just write this a little bit nicer so that negative 1/8 can pop out. 1 over square root of u, you can rewrite that as a power. So it's u to the power of -1/2. Oh, I made a mistake. This should be du. Du. There we go. And the antiderivative will be nice and simple. So remember, for powers, by the power. So dividing by 1/2 is the same as multiplying by 2. So I'm just going to do that instead. And then plus c. Let's make it a little bit nicer. So it'd be -1/4. U to the 1/2 plus c. And last step, rewrite it in terms of x. Squared plus c. Okay. So sub back in the u. Or if you want to write it as a square root, sometimes the textbook writes all their answers as square roots. You can do that. I'll accept either one. I don't care whether you write a square root for your final answer or not. Okay, so that's it. So that's the basics. We're going to do some special cases of the substitution rule now where you don't have like that inner function. When you have the inner function, and it's an obvious sort of anti-chain rule example like these three, then it's pretty straightforward. There's some sort of special cases that you need to be aware of as well. So let's look at these now. So first one is antiderivative of tan x. We actually, that wasn't in the table I gave you guys last day. We haven't done that one before. That's because the antiderivative is kind of complicated. So in order to do this, if you recall, I'll just put up here, recall tan x equals sine x. And if you ever need this identity, I'm going to give it to you on the test, so don't worry about that. Recall that tan x is the same as sine x over cos x. Oops, I didn't leave myself enough space. There we go. So this integral is actually equal to sine x over cos x. So this is kind of a composition. Well, it's not really even a composition of functions, but what we're going to do is make this the u substitution. So u equals cos x. Okay. So du by dx would be negative sine x. Rearrange it to cross multiply. So dx would be du over negative sine x. That's going to be my sub for dx. Okay. Okay. All right. So now let's sub in. So I'll have sine x over u times du over negative sine x. Oh, great. Look at the cancellation that happens. So you wouldn't necessarily know to do this example using u substitution, but if you were trying to do the antiderivative of tan x, u substitution might just be someone just happened upon trying this and it worked out. So it's kind of like trial and error. Okay, so worked out, we can cancel that, that's awesome. So really this is just, so the negative sign can come out, 1 over u du. Great, actually we know what the antiderivative of 1 over u is. It's ln mu. So this would be negative ln absolute value of u plus c. I didn't explain the absolute value part last lesson. The absolute value comes from the fact that ln is not defined for negative values, so you need to use the absolute value there. And then we just plug in our original. So negative ln of absolute value of cos x plus c. There we go. So strangely enough, the antiderivative of tan x, or the integral of tan x, involves a ln. So it'd be negative ln of the absolute value of cos x plus c. Okay, one more special case. Again, this one doesn't look like it's a composition of functions, but you can actually use u-Substitution. So, and we're going to do this one. We haven't done one yet with bounds on the integral, so we'll do this one with from x equals 1 to x equals e. Okay. So this one, we don't actually know the antiderivative of ln x. I'm just going to write that, unknown antiderivative. Oh, no, sorry. Yeah, derivative of ln x. So that's what we're going to make our u in this case. We do know the derivative of ln x, though. It's 1 over x. And so when you do cross multiplying, dx would be x du. And that's what I'll sub in for my dx. In this case, with the bounds, we also have to figure out what the bounds are. So at u equals, at x equals 1, the lower bound of this integral, u would be ln of 1, which would be 0. And at x equals e, u would be ln of e, which equals 1. So those you need to sub into the two bounds. Here's my integral now. I'm from 0 to 1 of u over x times x du. Great, there's a nice simplification we can do, cancel out those x's. So this integral becomes 0 to 1 u du. I think we can do the antiderivative of that. Just have to bump the power up by 1, divide by the power, and you don't even have to change it back in terms of x because we already changed the bounds into u values as well. So we can just evaluate this in terms from 1 to 0. So it'd be 1/2 times 1 squared minus 1/2 times 0 squared equals 1/2. Second. Okay, there we go. So let me just review what we quickly did here on the back page. So these are two special cases. I might say, so if nothing else is working, you might try substitution, even if it doesn't look like a composition of functions. But for the majority of cases that you're going to do today in the homework, you're going to see a composition of functions that show up for your antiderivative. Okay. I'm going to pause that there.